Hello. In this video, we're going to work on Gatekeeper. Gatekeeper is part of the offensive pen testing learning path on TryHackMe. And yeah, it is part of the Buffer Overflow section that we are finishing up. I have 2 rooms left, but I already solved both of them, so that's a good thing. I'm really excited to move on to the Active Directory portion. So yeah, let's just jump into it. Seems like I already start the server, and we have 15 seconds to ready up our Nmap and whatnot, our other VM. So I'm just gonna prepare that. All right, I'm on my VMware Kali machine. Also ran the window machine also, but we're not gonna go to that yet. So first thing first, we have to cd to thm. I think I already create a folder for Gatekeeper, so we're gonna see to that. You could make a dir like this to create a folder. And for those of you who are new, these are some of the script. pp.text is probably one of the command file that I have. Actually, let me sublime that. Yeah, so let's see here. Okay, so that's fine. I'm gonna keep that because it's also important too. And don't mind this. I'm gonna show you basically the right way and the wrong way to do it. I know most of the people who does this room doing it on Metasploit or with Metasploit, but I'm just gonna show you the manual way on how to basically get the privilege escalation. Before we going anywhere, let's start our Nmap because it's gonna take a while to actually scan. And yeah, so copy the IP here. All right, so the Nmap, keep it pretty much the same for pretty much every CTF, but this time I want to use Nmap tag T5 for the fastest scan, tag A for aggressive, tag VV for very verbose, tag PTAG for to scan all the port, tag PN to basically block pinging, because sometimes window machine doesn't allow us to ping. And it's basically we can't get any result if we don't use this flag. Tag on to output a file, and we're gonna name it as nmap. And then we're going to type out the IP or copy and paste it, let it scan. All right, let me go back to the browser tab here. I just want to point out that there are flags on this room, and I'm not going to show the flags, so keep that in mind. This room is created by the mayor. We've done a couple of the mayor room. I think relevant and internal is one of the room he created. And I just want to point out also that if you're struggling, if you're new like I do, and you want to get practicing and you want to get the right script to run, I recommend going on the same path here, offensive pen testing. Going to this room, Buffer Overflow Prep, to basically get all the script you need. As you can see here, there are 11 tasks, very long room. Took me about 8 hours to complete, but I really recommend doing this room because not only you get the script that is working, so all of these scripts are like working properly. Part of the reason why is the way that encode and everything is in Latin one and whatnot. And from my experience, using the script from the room do helps, and it actually get it to work, and it would speed up your process for those of you who are not really proficient in writing a Python script like I do. So I'm in the learning phase, so yeah. And also one more thing, if you want to make sure you're not confused throughout the room, break all these steps into the bullet point, because sometimes there are 2 steps in one line, but that's all my tip for you. So I just want to point out one other thing here, that is the update for all the thumbnail for the room. It's really great looking, honestly. It's refreshing to see the update on this. As you can see here, there are not only update, but update to the learning path itself. I did mention that I do a couple of SOX level 1 room, but I haven't completed yet because currently I'm focusing 100% on offensive pen testing, and make sure I prepare for the practical network penetration testing for TCM security, which I plan to do in about a month from now. So yeah. So red teaming is something I'm looking forward to, and maybe security engineer, and maybe I do SOC level 1 after I finish the test if I pass it. So we'll see in the future, but just want to point out that I really like the new graphics on this. Awesome. All right, so I think we cover every basis. Let's go back to our gatekeeper room. There are no write-up on this room. So again, I just want to be respectful to the creator, the mayor. I'm gonna keep I'm gonna keep the flags hidden. Basically, I'm not gonna print out the flags. And yeah, let's go back to our Nmap here and our Kali VM. All right, so we see some of these Samba port. If you're not recognizing some of these port, you know, if you see 139 or 445, it might be a Samba port. If you're not sure, you could try Google it. Port 139, the SMB port. 445 SMB ports. So to skip on ahead without waiting for too long for the Nmap to finish, we could try SMB client. Let me type out the syntax for this. I think it's tag SMB client, tag L to list all the share for the IP, and then we're gonna type the IP out. That's all we need. And once we ask for the password, just press enter without any password. You can see here there are 4 share, and the one we want to look at is user share. The reason why I want to look at it, because there are no comment on this, and then usually the first 3, the admin $, the variable or the IPC variable, usually have a password that we have to log into. But if the user disk is up or some other disk that have no comment or like not default looking, you can try to log into that. So the next up, we can do a SMB client 4// and then 2/ at the end of the IP, and we can type user, we can type no password on here, and you can see here we seems like we are logging in. We can press type dir. We see that we have default desktop share, and it seems like the share is we want to look at, but from this part here you can see here there are 00. Oh, I accidentally copy all the stuff by pressing middle click, but we could try cd to share for now. And there, so for some reason, if you look at the size of the directory, it looked like it's 0, but if you look into the directory of share, you can see gatekeeper.exe here, and that's the program we want to basically exploit. So we could get that, get gatekeeper.exe. So that is it. I think it's 13 megabyte, and if I'm not mistaken, we could cd out just in case and look at the default, and there are logs and whatnot, but I don't think there are anything interesting in this, but cd to desktop just in case. Yeah, so nothing interesting here. We can cd out and maybe exit, and that's it for SMB client. We could open up the folder. I like to use the GUI to look at what we have. Obviously you could do whichever way you want. I think it's gatekeeper.exe. So yeah, that is all we need. So once we're in the folder, I'm just gonna ls, we look at the gatekeeper.exe here. I'm gonna use python 3 hackm http server.server 80 for the port 80 to launch a local server that we could download stuff from, and I'm gonna switch to my window VM. So just a quick explanation here. There are a longer explanation I did on the brainstorm room. This VM is basically a Windows 11 VM that you could download the ISO from a Microsoft website. And the reason why I use Windows 11, because Windows 10 and 7 are really outdated, and they're not allowed you to download the ISO anymore. Unless you look it up on Internet Archive, or for Windows 10 you could try getting the Windows 10 Enterprise. But I like Windows 11 on for one reason, is the terminal program that you could use, kind of ls and whatnot. With it's more updated and it's more clean in my opinions. And also here I loop everything in the local file, so there are no internet connection. And all you need to basically run Immunity Debugger is to download Immunity Debugger on your Kali machine, the one that connected to the internet. And there are a lot of stuff in here, but don't mind that. Anyway, so delete all that. This is unrelated to the room. Keep this Firefox decrypt. We're gonna show that later. Actually gonna delete the @server.xex too. So all you need for the Immunity Debugger to run on the Windows VM is to basically launch a Python server like this, but from the download folder, and basically download the Immunity Debugger.xex setup here, Immunity Debugger setup.xex, and mona.py, and place the mona.py after you install the Immunity Debugger, and place it in let's see here, program file x86, Immunity Inc, and py commands. If you could find mona.py, it should be in here. So place the mona.py in this folder, and you could run Immunity Debugger and mona.py at the same time and get it to run basically. So that's the quick explanation. If you want a longer explanation, it's basically in the brainstorm. I think I covered pretty much everything. It's pretty basic in terms of installing VM, so I think it wouldn't be much trouble there. So I'm just gonna type out the local IP of the Kali machine. As you can see here, run from the server of the Python. As you can see the connection, get favicon. If you're gonna download the gatekeeper.exe, see if it let me download. Okay, download, it's fine. Open the folder, and I'm gonna move the .exe, I keep saying xex, that's the problem I have. So .exe to the gatekeeper folder that I created from the last time when I tested. So every time I launch the exploit, for some reason it get deleted, but it's not a problem, just re-download it. It should be fine. So that's all we need. To gatekeeper.exe is in the desktop folder on the Windows VM, and that's all we need. We can launch Immunity Debugger, and then we choose file, and we could choose open. And then if you never run it before, it's basically go to out all the way to C, and then user, I think, try to find desktop. That's where I stored the folder at, and then gatekeeper.exe, launch that. That is basically how we run gatekeeper.exe to debug it on Immunity Debugger. Let me press X first before I do anything, and we're gonna look at our Nmap. Finally, our Nmap is finished scanning. So there are many ports we could look at, but the one that we want to note is the port 31337. That is the one we want to look at. And to test that, since it is a buffer overflow room, we're not going to do any more enumeration in terms of like HTTP and whatnot. I don't think there are an HTTP port we want to look into either. So we're going to skip a lot of those enumeration. We're going to go ahead and type netcat and copy and paste the IP. And we want to type out the port of that binary that it was running. So 31337 is the port we want to look at. So to do this is basically to grab the banner on a regular CTF, but on this we basically make a quick connection to the port and IP. Am I on the right port? Seems like it. Okay, any connection here? Did I connect to the VPN? Looks like I am. I don't know why it takes so long. Let me try running this the gatekeeper.xex on here instead. So it's say waiting for connection, and the IP for this is this IP. Oh, so it is running. It just doesn't give you any result. Let me try that again on the room ports. Okay, so it does say hello back. So we're just gonna type and type. So this is how it works. All right, so we see our end when we connect it to the port and the IP, but we can't see what the other end is like. So that's the reason why I ran this program on here. This room is pretty simple in terms of getting the exploit to work. We just want to test and see what the maximum bytes that this program accepted. Again, I am running this program locally on this Windows machine. So see here, byte receive is 1, byte send is 10 and whatnot. And I'm just going to connect back to it again. And then I'm just going to type random number, and I could do okay. So we're going to type out a lot of random character and number and basically see what's the maximum bytes is. Oh, it's basically crashed the program. So that's funny. Again, I want to double check. So if I do hi, we see 3 byte receive, and if I do this much, copy and paste that, and basically the program is crashing. So that's a telltale sign that the byte that it's allowed to receive, or the space, the buffer it allowed to receive, is very small. So we could try to fuzz that. Actually, we're gonna replay the program on the Immunity Debugger and press the red button to play. We're gonna launch the fuzzer.py. Actually, I'm gonna change this with the original room fuzzer.py. 1 second, let me open up the tab for this. Again, I recommend using all the script from the Buffer Overflow preps. It does work, and it worked really well. Instead of going to Tiberius GitHub, it is the same creator. Tiberius is the person who created Buffer Overflow prep room, but Tiberius store scripts for buffer overflow, but these one doesn't really work as well as the one that he written down on the buffer overflow prep. That's the reason why I'm using this. Just change everything again. Got the IP again. So first thing first, we want to fuzz how many bytes that it takes to get the program to crash. So we want to type out the IP. This is a local IP. We want to test it locally first before we try it online, or or straight to the target. So this is all we need. Python script gonna basically run straight to the IP in the port and do a while loop. Basically it's gonna try to send a string of A for 100 bytes at a time, and it's connect to the port, and it's try to fuzz with the 100 byte at a time until it crash, basically. Except when it crash, it's gonna tell us fuzzing crash at whatever bytes that it crash at, and turn off the program script and stop. That's simple. It's not more to that. So fuzzer.py, we're gonna run it with Python 3. Fuzzer.py, make sure you're playing it on this machine with your Windows VM. Seems like it's not running. Blind disconnect. Crash at 100 bytes. Alright, so the program seems like it crashed at 100 bytes, and that may be the right way the way it is. And I remember correctly, it was like that when I was running it. So to make sure we verify that it is crashed at 100 bytes or around that, we could run it on outside the Immunity Debugger. CD to desktop for now. CD to the gatekeeper. And then we're gonna launch gatekeeper.exe. Again, on this side, it's basically listening to the connection. We can do the same thing again. Use connection from remote host. Client hand off to handle a threat. Client disconnect. So it's basically crash at 100 bytes, around 100 bytes. So we could say that the buffer size is really small, and then it crashed at around 100 bytes or 150 bytes or so, somewhere around that. So to make sure that we are correct, we could start. Actually, let me name this as Metasploit. Hold on. Let me launch another view tab, and I'm gonna name this as, can I name it? Name the tab, and I'm gonna name this as Metasploit. Keep this for now. I'm gonna name this as Fuzzer. Gonna name this as exploit, and these two I'm gonna keep it blank for now. I'll keep it the way it is for now. So we could try setting the pattern to this in the payload. So we could try pattern create. So pattern create, we're gonna add 400 to the 100 byte that it crashed, so it is 500 total. We just want to add a little bit more, give it a little bit of padding. So this is the amount of byte we want to send to. We want to copy the result of actually, let me copy a new Python script for the exploit and adjust that to the IP. So this is the second step after we fuzz it. So port, we want to delete the overflow prefix, and then we're going to copy the result of the Metasploit framework. It is stored in user share Metasploit framework tool exploit pattern create.rb, and we're going to use tag L for the length. It is 500. So we want to add 100 bytes more than 400 bytes more than the 100 bytes that we just fuzzed. If it crashed at 100 bytes, we're gonna add 400 more. We get 500. If it crashed for 1500, we're gonna add 1900. So this is 500. Make it simple. Oh, copy the wrong place. We're gonna paste this on this payload. Make sure there are no space within the quotation mark. Save it, and now we're going to go to the exploit. We're going to type Python 3 exploit.py, get that ready, restart the program on Immunity Debugger, launch the exe with the red play button, run the exploit.py. You see here the ESP, it seems like it's output the payload we just sent, but the EIP is still pretty much default. But to make sure, we want to look at the offset for this. So this is the next step. We're going to use the offset command for Mona. It is Mona find MSP distant 500 is we want to look at. Right, we're going to press enter on that with the command line, and we want to look at the examining registers here, and we see the EIP contain normal pattern offset 146. So it is pretty small. The buffer is pretty small. The offset is 146. That seems like it's going well. To verify that the offset is 146, we could go back to the Metasploit tab here, and then we're gonna press this, want to check the register for this. So the Metasploit framework we want to look at is in user share Metasploit framework tool exploit pattern offset.rb. I'm going to zoom in a little bit more. Tag L for the length that we just sent to, and it is 500 is the length, the same length that we generated with the Metasploit framework for the pattern create. So that is the length. Oops, something is, I kept pressing enter and I keep going all the way up again. But anyways, and we want to also use tag Q for the query. We want to look at the register address. So there's 39654138, 39654138, the same address that I typed with my test run. And there it is. It also confirmed that it is at the offset 146. So we are correct on this. So we double checked it and seems like we're on the right path. That is good. Next up, we're going to go back to the VM, the window VM. I'm going to copy this line. Give me 1 second. So first thing first, this is your first time doing this on Immunity Debugger. Make sure you copy this line. Mona config set working folder at cmona send it sign p. So basically create a working folder for every time you run a Immunity Debugger or try to debug a binary, and it's basically going to name the folder to the exe name. So if you've done this the first time ever, make sure you copy this line first thing first once you launch the Immunity Debugger. Already done that. I forgot to tell you that actually. So make sure you follow every step on the Buffer Overflow prep. It tell you basically everything. So once we have the working folder set up, we should create the byte array. So mona byte array tag b /x00 in quotation mark, and it should generate this default byte array.txt, and it's stored in the C folder mona gatekeeper, and it should store in here. So this is where it's stored at. You can see here the argument is byte array tag b x00. That's all we want to see. So this is the default byte array we want to look at, and the next up we want to use the Python 3 byte array.py. This is basically the same default byte array x00. We want to go to exploit.py. Let me move that forward. So you could copy the byte array.py result onto the payload and put it in quotation mark and then parenthesis on both ends. And I also want to change the return input here to BBBB for 4B. It doesn't seem like we took control on of the EIP here. It still says 3965 4138, but it doesn't say like 4140. It should say 41 41 41. But we wanted to test that. It seems like the offset is correct, but they still have some sort of buffer going on. So I want to check this real quick. So it's not that big of a deal. I think the exploit should run normally. So save this. So this is all we need, the IP. Oh, also the offset, we want to type 146 into our offset because we found the offset on this. And then offset return number, return section to BBB. I skipped one step with this. We could do this 2 times actually, but we'll do everything at once. We have payload. So the byte array we generated, save that, and then we're going to go to the exploit.py, make sure we restart the program, run it with the red play button, and run the exploit.py again. And you can see the EIP on this. Seems like it changed the way we wanted to change. It going to 42, 42, 42, 40, and it's basically mean BBB in hex, I think. And the ESP on this is B819E3. So we basically going on to the next step of the Buffer Overflow prep. We can basically compare this to look at the bad character. Let's see here. Make sure I want to verify. So, okay, so it is gatekeeper, the same way it's spelled on this. Oops, so there are 2 exclamation points. So the way we compare this is to type exclamation point mona compare tag F for the folder or the file, and then it's stored at C mona gatekeeper, so the name of the executable we're testing, and the byte array.bin, and we want to type out the ESP register address. It is 00B819E8. Let me screenshot that because I noticed my node have a bit of problem. So copy this to my node here, and we find the possible batch character. It's say 0008, so it could be the byte character we want to look at, so we want to keep that in mind. And just to give you a little bit of spoiler here, if you see something like this, like a really small amount of bad character, like 2 or 3 bad character, it should be the right bad character we want to look at. So the mayor, the room creator, kept it simple. If you see something like this, like around 9 bytes, or not the 9 byte, but like if you see the 0008, if you see something smaller than say 5 character, if you see more than 5 character, it should be you should do the find bad character twice, 2 times or 3 times. But if you see something like this, that should be our bad character we want to look at. So let's save that. I don't want to go any further, but I want to test though. I want to check if it works. So if you see 0008, or you see something small as this one under 6 or 5 character, this should be the bad character we want to look at, a Badchar we want to look at. So we could try generate a NSF Venom with this, and I'm going to change this to the IP I'm currently using. Got what it is, so let me type IP A. I'm going to copy the Ethernet 0, paste this onto here. So that should be fine. So we're going to type NSF Venom tag P Windows shell reverse TCP. This is the unstaged payload with the L host of our local Ethernet 0 L host, the IP, and L port is the port we want to listen to. Exit functions thread, tag B for the bad character, and tag F for the file. For some reason it copy L host in there too, but it should be C in C, and press enter to generate the payload. Copy that, paste it onto our payload section. Say that for now, and I'm gonna add the no-op padding on this. So /x90 times 16, that's the minimum we want to add. I want to find the return address. Basically type this out, the Mona JMP tag R ESP tag CBP, and then backslash the bad character we want to look at, so 00x08, and we want to copy this this jump point here in reverse, so from the first 2 letters first, so C3 140408. So on our payload we should type /C3 /14 x14 /x04 /x18, if I'm not mistaken, or x08, actually x08. So this is all we need. I'm gonna zoom out a little bit. So we find the port, the IP, the port, this is a local IP for now. Offset is 146, return address is the jump point, so we type this in backward, and we're gonna type /x90 for the no-op, and then time it by 16 for the minimum of padding. And the payload we generated from the NSF Venom with the Badchar of x00x08. The reason why I keep this pretty simple because I'm already an hour in, and from my experience from doing this before, going over the finding Badchar over and over, and it's basically looped me around to this bad character anyway. So just skip that. You don't need to find the unmodify for Badchar the same way as the Buffer Overflow prep room. But if you see something this small, I think you could find the Badchar, and you could find the correct Badchar and run our exploit like that. So keep that in mind. That's just my recommendation. So we're gonna close this out on Immunity Debugger. I'm gonna go back to this again, and I'm gonna run the gatekeeper.exe. I'm gonna split this vertically. Type netcat for the port 4444 we want to listen to, and run the exploit.py, and the byte receive 400 send fail. Seems like it's not running. Want to test that again. Let's see, make sure I did everything right. L port, L host. Want to check my Python script or my Metasploit framework. Seems like everything should be running. So I save that actually. Let's see. All right, let's try exploit again, and we got it. So type who am I here, should be the desktop name, and this time it doesn't crash, so that's a good thing. All right, so nothing really changed. I got the exploit to run properly. It just doesn't work on its own. All right, so next up we see that the Buffer Overflow exploit is running on our local VM. We want to connect it to the target VM. So we're going to go back to the NSF Venom and type out our IP 10.13.47.211, generate that, copy the result, and then change the IP input here to our target machine IP. Let's see here, it should be 10.10.150, save that. That's all we need to configure is the payload and the IP if we want to connect it to the target machine. Go back to our exploit tab, run our exploit.py, and we get connection to the target machine. If I type who am I, we are gatekeeper, and on here I think we could dir it to find a flag, right? Okay, we could also find a flag on natbat desktop, but I'm not going to type out the flags. So to keep this simple, there are many ways to enumerate this, but if you go back to the room I forgot to read the description, but it should say on this second task here. Let me switch back to this tab. So defeat gatekeeper and pass through the fire. Defeat the gatekeeper to break the chain. Beware, fire awaits on the other side. What does that mean? It might mean a firewall, but if we're trying to check for a firewall, let's see here. If there's a firewall running, we shouldn't be able to connect to this. If I type this out, no, it doesn't work. It's on an old machine. It's actually using netsh firewall show state, I think. Okay, if I type this out, netsh firewall show state, the profile is standard, operational mode, disable, exceptional mode, enable, notification mode, disable, broadcast response mode, enable, remote admin mode, disable. It seems like it's not working. It seems like it's not running. No port are currently open to all network interface, but seems like there are no firewall connecting right now. But if I cd out and then maybe dir to program file, actually you have to type it in quote like this, in program files x86, close the parenthesis and then quotation mark. If I dir this, you can see Firefox here, and then without doing much enumeration, if you look at the date, let me zoom in a little bit more. This is so new. So 4/21/20, 10:57 p.m. Mozilla Firefox. So without even running linpiece, reading the room description. Oh, I forgot to switch the tab. So what I ran is basically this: netsh advanced firewall dumb, and I cd to program file x86. If we read the room description, we look at the date here, 4/21/20. Look at compared to other dates on this, everything is around 2011 is the latest, and this is 2020, and we see Mozilla Firefox. So we can assume that this is where we want to exploit. So yeah, actually this is what we want to exploit. So we can cd back to user natbat. I think it's stored in user natbat. And if you type dir/a, we want to look at everything in here. There is AppData in natbat. So usually this is where the profile for firewall is stored at. AppData. We can cd to AppData. There again, there are roaming, local low. I think it's stored in roaming if I'm not mistaken. Let's cd to that. There again, you see Mozilla. There again, cd to Firefox. So we can assume that this is the profile we want to look into. If I cd the profile, so this is full length actually. You could type this all at once, but the way I found it is something like this. So this is what we want to look at. It's in C, user, natbat, AppData, roaming, Mozilla, Firefox profile. The reason why I know this, honestly, this is from my personal experience. If you copy this profile here and store it to a new drive and basically import this one of these folder into the new Firefox you just install on your new PC. Little tip here, it should get it to run with all the login account in it. So this can have like login like information in here, credential, all that kind of stuff. It should be in this folder. So we can assume that this is where we want to basically run. So we are here. We can look into this more, or basically run a Python script or a script from GitHub. All you have to do is search for Firefox Decrypt.py. Seems like I bookmarked it on my Firefox, and all we need to get is this Python script here. So this is created by Unode, and it has 303 forks, 2k star. It seems like it's everybody liking this, trusting this. So we already downloaded. I already downloaded it. So I'm just gonna move this to the room. PHM gatekeeper. Keep that. Next up, you could either run Metasploit. Again, I'm not gonna use Metasploit on this. I'm gonna keep everything pretty manual. It's gonna take a while, but it is what it is. Okay, so let me ls and delete everything. rm tag f share, actually tag rf, delete the share, and then rm tag rf lj whatever. So I want to make everything fresh. So you see here, I delete the folder because you see a little bit of spoiler there. So I delete the folder. I want to make sure I show it in a demo. So all I need to do is make a share folder. See here, ls.share, ls. If you see share folder here, I just delete it. You know, I could have cd to this and start doing the exploitation, but I want to make everything new, make everything fresh, show every step I took. And we can do a sudo mount on here. So we could type sudo mount tag t cifs, so basically mounting to the SMB server or SMB share, and we do a we're gonna type out the IP 10.10.150.158 to users, and then this is the share. This is the folder we want to store our share to. Share. So that don't get confused. This is the folder we want to store to. This is this folder, and then read write username guest. That's all we need. So this is how we mount the Samba share to our share, and it asks us to type the password for guest. We don't need to type anything, and it's basically mount the SMB share to us. I got this method from Bastion on Hack the Box. So if you're confused on what's going on, we're basically mounting a share to mounting the SMB share to our computer basically. And then we can cd to share, ls, cd to share again, ls. Oh, not here actually. Let me. Oh, not yet. We can copy the folder to here. Let me 1 second. So cd out for now. The way I did this is to copy these two folder to the share, and I think it's stored on. Let me save this path first. Cd out for now. I want to look at where the user share is at. So user cd users. Oh, it is in share. cd share. The many time I mentioned share. So this is where it's stored at. So I'm on the correct path actually. Let me cd to share for now on the Kali machine. There's a lot of words share, but don't get confused. I think this is where we store it. So yeah, so if I dir or ls, you see gatekeeper.exe. Again, I'm mounting a share on a local Kali machine. So this is basically this. Okay, the user share, we see gatekeeper.exe. We found gatekeeper.exe on user share on here too. So this is how we mount it. So now all I need to do is copy the folder. Right, this is how you copy it. I forgot the command for a second. Here we are. So 1 second. So this is how we copy the folder to user share. So basically we're gonna use xcopy. Oh, there's a lot of space in here. One more second. See if it worked. Let me try this. So file copy because I copied it the wrong way. Let me do it again. Why I keep doing this? Okay, hold on 1 second. Xcopy. All right, seems like it works. Okay, so that's good. So all I did was type xcopy, the path of the profile, so the Firefox profile. So it's in user, natbat, AppData, roaming, Mozilla, Firefox profile, LJ, FN, etc. And we want to do where we want to copy it. So C user share in quotation mark, and we're gonna use /e/i to copy all the subsidiary for /e. /i is the indicate that the destination is a directory. So that's all we need to do. We basically copy everything from this folder to the user share. So if I ls on this, you could find everything in here, including the gatekeeper.exe. And if I run the exploit, so python 3 firefox decrypt.py, and then we want to go to home Kali. Let me print the directory on this actually. Copy that. That is it. So basically mount a share, copy everything to the share folder. So the profile, so the folder we want to copy is the LJFN812A. There's one more step we could do, but I kept this really simple. So this is the simple step we want to do. After we mount the share and copy the Firefox profile on the share folder here. This is where I want to copy to. No, not. How do I print directory on window? I forgot about that. Print directory on window. Basically do a dir. I forgot about this. So if I dir, you can see here on user share, I copy everything on here. The one that the room created originally stored the gatekeeper.exe. I basically copy everything. It's a little bit sloppy, but you know, it works. And if it works, it works. So this Firefox Decrypt.py here is to basically go into the folder and try to look for the credential within the folder. So you try to find profile.ini and every SQLite or SQLite. So it basically tries to decrypt everything in here and look for a credential. And when it finds a credential, it's going to basically output the username and the password for us. And if I see the out on user here, you can recognize that the mayor is a user on this machine. So we can assume that this is the credential for the mayor. And next up, there are two ways we could do this. One, I like to use cd to user bin, and I like to use Impacket Psexec. You see here, I already done it. So this is the manual way we could do it, is to do this, type the domain. So if I never done this before, I would type psexec like this. Look at how the syntax goes. Is basically give us the domain. We type username and then colon password at the target name or the address. So psexec gatekeeper is the domain. We found that out on the Nmap. If you look at the Nmap scan, there it is. The domain of this machine is gatekeeper. So we want to type that out, and the mayor is the user we want to log into, and the password, basically got the password from here. So that's how we do it. Again, we mount a folder, the share folder, to our Kali machine and copy the profile onto the share folder, and we basically use the Python script to basically decrypt whatever in the share folder here, whatever is in here. Usually it look into like most of these SQLite file to find the credential, basically decrypt it and give it the password. And now we want to log into the machine with the mayor credential. Press enter. So this is the way they type the syntax, or the way they type the connection. It should be in right now. Am I in? Does it work? Okay, for some reason it doesn't let me log in. Did the room expire? No, it still have 34 minutes left. Oh, because I typed the wrong IP, that's why. Okay, that makes sense. This is the old IP. So we connected with the new IP. It's basically Impacket Psexec. It's basically create a file, get a new PID, log in with the credential, and if I type who am I, we are NT authority. So if I cd to mayor, if I try cd to mayor on this, we can't get any access. We can, but we can't look at the file. So we cd to desktop, got the E. See, access denied. So if I do this with natbat account from the Buffer Overflow, we have no access. Now we log in with the mayor credential. We are NT authority system. We can see the to user. Let me zoom in a little bit more. Mayor desktop there. You can see here we find the root.txt, just the proof of work, a proof of concept, whatever proof of me doing this is. I'm gonna cd to user natbat. Actually, I'm gonna copy the whole line. I'm gonna write it on my note and copy the whole line for you. All right, this is the line I want to type. So this is basically a one-liner to look at everything. This is the OSCP style on looking at the flags. So it is cd to the natbat desktop first, and then type nn. The reason why I use more, you can see here there are two extension .text. If you write down types user.text.text, it won't let you print the flag, so you have to use more to basically look into the file here. And I'm gonna cd to user mayor desktop and type more again. You see here root.text.text, and I'm gonna type nn IP configs and then nn date /t. I'm gonna print this and I'm gonna blur it basically, so you won't see the flags, but I just want to show the proof of me getting the exploit and everything to work, privilege escalation. There it is. Boom. And that's it. I'm not gonna scroll up and down because I don't want to mess up the blur. And this is the flag, first flag. It should say something there, and the end it should say D, and then the end of the flag should say U, something like that. All right, and this is the IP 10.10.150.158. The date is today. That is it for this room. Actually, there's more thing I can do is to use our desktop of Fuzzing, or see here, this can I do evil WinRM with this too? Actually, let me try Xfreerdp. Can I do oh I forgot this tab is really slow. Forgot about that. I mean, this tab doesn't matter. Xfreerdp. So we could type the mayor. So we could try to log into the, let's see if I could log into Xfreerdp. Anything? Oh, we are logged in. Yeah, we are logged in, so that's good. So we're basically using the same credential with the mayor and with the IP, and seems like we can't really log in. It just set us in. Oh, we are logged in. Oh, nice. Okay, so we see root.txt here, but can we look at user.txt? Oh, there it is. Okay, so again, this is where user.txt at. Just to confirm, I did a mess on the share folder, and there it is. So we copy everything from the Firefox folder in the share folder. So that's how I made a mess in here. If it was the default, it should say, you know, just the gatekeeper.exe, which is in here. Anyways, that's it. That's the room done. I hope you have a wonderful day. I'm not gonna print the flag, obviously. No. Hope you solved this. Hope this helped. Again, all the step you need for Buffer Overflow is the Buffer Overflow prep room. I'm gonna try to link it down below. My channel is not verified yet in terms of, like, nowadays with the terms of service on YouTube, you have to have a certain amount of view or something, or do a video verification, which I'm not gonna do. I'm basically try to build up the history on my channel and basically get the privilege to link all the links, the useful link in the description. But if not, you know, just search Buffer Overflow prep on TryHackMe. You should follow all those steps from the room. Should help you out with the Buffer Overflow. And this, I kept it pretty simple. So all we need to do with the exploit, with the privilege escalation, is to use xcopy and then paste out the path of the Firefox folder to the user share. That's where the SMB share is stored at, and copy everything on this, and basically mount the share to our local folder on Kali. After that, we could run the Python script to basically try to decrypt whatever credential in the share, get our password, and log on to the machine. And basically, we got the flags. Basically, we get the login to this, or do it, you know, on the terminal. That is it for this room though. Hope this helped. Hope this is not confusing. I'm doing my best here. This is pretty much manual, no Metasploit involved. If you want to look at the Metasploit step, please look it up with other people write up and whatnot. It should be this similar thing, just the way you run the Metasploit is basically change the payload for the Metasploit. So NSF Venom should be, say, window interpreter reverse TCP, something like that. Basically copy the payload to your Python script and basically run a multi-handler module on your Metasploit, and basically, you know, run the exploit and get the Buffer Overflow to connect back to the Metasploit, and run the post exploitation with this Firefox decrypt and try to do similar thing and basically get the credential. But this video is long enough. I'm not going to do this step, that Metasploit side of thing. Just to confirm here, this is the same room you see here, 10.10.150.158, and I got all the flags. One more thing, wow, look at this new update with the profile page. Really cool, but it cut out the year. So anyway, I got 333 days of streak, so hey, we're getting there. This is really cool though. I like it. And I like how we look at the page of the completed room now, so I could track how many room I complete and see what's next. I already complete retro and stuff. This is such an easy room. So the next few video, I'm gonna do a video on this actually. The retro is gonna be probably the next video, not the next video, but the next video. And yeah, I ramble long enough. I think I keep saying goodbye, but this is the final goodbye for the day. All right, bye bye.